the model first. The name of the chapter is the Laplace transform. The introduction about the Laplace transform is, so earlier I have stated the differential equation with initial conditions, and in that differential equations we are finding the first the CF, the complementary function. Then we are using the initial condition to get the PI, the particular integral, by using the Laplace transform technique. So we are going to find out the solution of the differential equation arising in mechanics and electrical engineering. Then we are finding the direct solution of the differential equation. The first of all, we can define the Laplace transform. The definition of the Laplace transform is that if f of t is the real valued function, then it is defined as the LT of f of t. So capital L indicates the Laplace transform, and Laplace transform of the f of t is equal to the integral form 0 to infinity and e raised to minus st f of t into dt. Then the linearity property of the Laplace transform are 3. So here k indicates the constant and f of t is the real valued function, and LT of k into f of t is equal to k is outside, k is a constant, and LT of f of t, the LT of f of t plus g of t is equal to g of f of t plus LT of g of t. And third property is where alpha and beta are the two constants, and f of t and g of t are the two real valued functions, and LT of alpha into f of t plus beta into g of t is equal to alpha and beta the constant. We can take outside alpha into LT of t plus beta into LT of g of t. And these are the three properties of the Laplace transform. Now we are going to find out the standard Laplace transform of the some functions. Laplace transforms of some standard functions. Laplace transform of some standard functions. In that first one is the LT of a constant. LT of a constant. Let f of t is equal to a, where a is a constant. And you can, by definition, you can find the LT of the constant wave function by definition. So LT of a is equal to, so LT of a is equal to, so integral from 0 to infinity e raised to minus st k into dt. A into dt, and a is a constant, take outside, and integration of e raised to minus st is equal to e raised to minus st by minus s, where s is a parameter and t is a variable, and if integrated e raised to minus st by minus s is the integration of e raised to minus st, and integral from 0 to infinity by. Now here minus s is a constant, we can take outside. It becomes a minus a by s into e raised to minus st from 0 to infinity value. Now we can apply the upper and lower limits, and it is equal to, so minus a by s into bracket e raised to minus infinity minus e raised to 0. That is equal to minus a by s into bracket, it is e raised to minus is equal to 0 minus 1. Then that is equal to minus into minus becomes plus a by s. That is the LT of the constant a is equal to a by s is the first formula. This is the LT of a is equal to a by s. In particular, if you take a is equal to 1, in particular, if a is equal to 1, and it becomes LT of 1 is equal to 1 by S1. In particular, A is equal to 1, then LP of 1 is equal to 1 by S. So these are the LP of a constant A is equal to A by S, and LP of 1 is equal to 1 by S1. Then we put the second LP of a function, LP of e raised to 80 value, LP of e raised to 80. Again by definition, the LP of e raised to 80 is equal to e raised to 80 is equal to integral from 0 to infinity e raised to minus st into e raised to 80 into dt. And here e raised to minus st, e raised to 80 both are exponential functions. We can add these two functions. That is equal to, so integral from 0 to infinity e raised to minus s minus a into t. So here minus is common. So minus of s minus a into t into dt. Now we can integrate e raised to minus s minus a into t with respect to t. It becomes e raised to minus of s minus a into t divided by minus of s minus a from 0 to infinity. Now again we take the constant outside, so it becomes 1 divided minus 1 divided by s minus a into bracket e raised to minus of s minus a from 0 to infinity. Now you apply the where the upper limit is t is there, t is equal to infinity, it is the upper limit, and t is equal to 0, it is the lower limit. Now you can take the that is equal to, so minus 1 divided by s minus a into bracket e raised to minus infinity minus 1 or e raised to 0 1 e raised to 0, that is equal to minus 1 divided by s minus a into bracket 0 minus 1 and minus into minus becomes a plus. So 1 divided by s minus a is the LP of e raised to 80 value. Therefore, the second formula is LP of e raised to 80 is equal to 1 divided by s minus a where s is greater than a value. This is the second formula. LP of e raised to 80 is equal to 1 divided by s minus a. Then third formula is just to replacing a by minus a. A by minus a, we get the third formula is LP of e raised to minus 80 is equal to, so 1 divided by s plus a value. So this is the third formula. LP of e raised to minus 80 is equal to 1 divided by s plus a. What is the third one?
Yes plus yes.
Hello? Next one is LP of the hyperbolic sine of 80. LP of hyperbolic sine of 80. Then by Euler's formula, so hyperbolic sine 80 is equal to e raised to 80 minus e raised to minus 80 divided by 2. So this is the definition of hyperbolic sine 80. Now you apply the LP of hyperbolic sine 80 value. So therefore the LP of hyperbolic sine 80 is equal to the LP of e raised to 80 minus e raised to minus 80 by 2. Okay. Then we take the 2 is outside, that is the 1 by 2, and LP of can separate LP of e raised to 80 minus LP of e raised to minus 80. Now I can apply the, already know that the LP of e raised to 80 as well as e raised to minus 80 value. Now that is equal to, half into bracket and e raised to 80 its LT is equal to how much? 1 divided by s minus a minus the LT of e raised to minus 80 is equal to 1 divided by s plus a value. Then after getting the LT of both the functions, now you have to get the LCM of these two functions. Now that is equal to the LCM s minus a s plus a are the two LCMs. That is 1 by 2 into bracket. So s minus a into s plus a is the LCM, and that is equal to s minus s plus a into 1 s plus a minus s minus a into 1 s minus a. Then open the bracket. If you open the bracket, so it is a minus s plus s get cancelled. Then what is the a? Sorry, minus to minus plus a becomes a 2a value. That is equal to 1 by 2 into bracket. So 2a divided by, so s minus a s plus a. If you multiply these two by using the formula a minus b, a plus b is equal to a square minus b square. That is the s square minus a square. And here to get cancelled, then the answer becomes so a divided by s square minus a square. So this is the LP of the hyperbolic function sin of 85. So LP of hyperbolic sin is equal to a divided by s square minus a square. So similarly, we can get the LP of hyperbolic cos 80. LP of hyperbolic cos 80. So again by Euler's formula, hyperbolic cos 80 is equal to hyperbolic cos 80 is equal to e raised to 80 minus plus e raised to minus 80 by 2i. And again apply the LP on both sides. So LP of hyperbolic cos 80 is equal to the LP of what is the hyperbolic cos 80 e raised to 80 plus e raised to minus 80 by 2, and hyperbolic cos 80 is equal to e raised to 80 plus e raised to minus 80 by 2, and again one bit is outside. You can apply the LP for both the functions by using the linear property. So LP of e raised to 80 plus the LP of e raised to minus 80. Then we can apply the LP of e raised to 80 already known, what is the 1 divided by s minus a plus the 1 divided by s plus a is the LP of e raised to minus 80 value. And by taking the LCM again, what is LCM? S minus a, s plus a is the LCM. The LCM will the first denominator, s minus a get cancelled, remaining s plus a into 1 becomes s plus a plus so s minus a. Now in these two terms, so here minus a plus a get cancelled, and s plus s becomes it is the 2s. S plus s with the 2s divided by again a minus b, a plus b is equal to a square minus b square. That is the s square minus a square is the hyperbolic cos 80 LT. So LT of hyperbolic cos 80 is equal to get cancelled. What do we mean now? So s divided by s square minus a square is the LT of hyperbolic cos 80 value is equal to s divided by s square plus a square. So this is the Laplace transform of hyperbolic cos 80 value. Now get to the next kind of function. Next, the fifth one is the Laplace transform of sin of 80 and cos of 80. These are the two trinity functions. Now earlier we got the LP of a hyperbolic function sin and cos 80 values. Now next is the LP of hyperbolic, that is sin 80 and cos 80. We know that the e raised to IIT is equal to, what is raised to IIT? E raised to IIT is equal to the cos of 80 plus I into sine of 80. So this is the LS function. So e raised to IIT is equal to cos 80 plus I sine 80. Now I can apply the LT of this function. Now this is the apply LT on both sides. Apply LT on both sides. So that is the LT of e raised to IIT is equal to the LT of cos of 80 plus I into sine of 80 value. So after applying the LT of e raised to IIT is equal to LT of cos of 80 plus I into sine of 80. Now by using the second formula, so LT of e raised to 80 is equal to e raised to 80 is equal to 1 divided by s minus a. Okay, by using this formula, we can expand the LT of e raised to I80. Now what becomes so this is the 1 divided by s minus ai. That is equal to, by using the linear property, we can apply the LT for both the functions where I is a constant. Therefore, it becomes a LT of cos of 80 plus I is a constant and LT of sine of 80 value. Now left side we can take its conjugate. To simplify this function, 1 divided by s minus ai, we can take the conjugate. Therefore, the LT of this implies, so LT of cos of 80 plus I into LT of sine of 80 is equal to 1 divided by s minus ai into, we can multiply s minus ai its conjugate is s plus ai. S plus ai divided by s plus ai. Then after multiplying this conjugate, we can multiply. So the multiplication is that is equal to, so LT of cos of 80 plus I into LT of sine of 80 is equal to, so 1 into s plus ai is equal to s plus ai. Denominator side we can multiply by using the identity a minus b, a plus b is equal to a square minus b square. It becomes s square minus a square into I square. Then I square is equal to, already know that I square is equal to minus 1, and using this I square is equal to minus 1, the above function will become so s plus ai divided by s square plus a square, because I square is equal to minus 1, minus into minus becomes a plus a square. Then you separate the denominator. Therefore, the LT of cos of 80 plus I into LT of sine of 80 is equal to s divided by s square plus a square is the first term, and I is a constant, take outside, and a divided by s square plus a square is the second term. Then again, comparing the real and imaginary part. Compare real and imaginary part. On both sides, we get the first term is, we get the LT of cos 80 is the real part. So LT of cos 80 is equal to s divided by s square plus a square. That is the LT of cos of 80. And then imaginary part, I will cancel both sides. The LT of sin 80 is equal to LT of sin 80 is equal to a divided by s square plus a square. So these are the LT of the derivative function cos of 80 is equal to s divided by s square plus a square, and and LT of sine of it is equal to a divided by s square plus a square. So these are the two more functions. Its Laplace transform. Now we go to the next standard function. So if the algebraic function is to n, where n is any positive integer. So t is to n. Again, by definition of Laplace transform, by definition, the LT of t raised to n is equal to LT of t raised to n is equal to, so integral from 0 to infinity t raised to minus st t raised to n into dt value. Okay, so LT of t raised to n is equal to integral from 0 to infinity t raised to minus st into f of t value t raised to n. T raised to n into dt value. Now to simplify this integral, you have to give the substitution here. Put st is equal to x. St is equal to x. This implies only t is equal to x by s. X by s. Now get differentiate. So dt is equal to dx by s value. And when you take the substitution, st is the variable in terms of x, and you can change the limits also. When t is equal to 0 and x also becomes a 0 value, because t is equal to 0, 0 to x becomes 0, x also becomes 0, and when t is equal to infinity, so infinity into s also infinity, so x also becomes a infinity value. So the limits are unchanged. That is the t is equal to 0 to infinity, x also becomes 0 to infinity value. Substitute all these values in the equation number 1. Then the equation number 1 implies LT of t raised to n is equal to, so t raised to n is equal to, so integral from 0 to infinity and t raised to minus x. St is equal to x and t, what is t value? X by s. X by s raised to n power into dt. What is dt value? So dt is equal to dx by s. Dx by s. Now we will simplify this function. Therefore, the LT of t raised to n is equal to, so integral from 0 to infinity t raised to minus x into x raised to n by s raised to n into dx by s. After subtraction by this system, x by s raised to n can be as x raised to n divided by s raised to n value. Then this becomes this value, and we can s raised to n, s raised to 1 becomes s raised to n plus 1. You can take outside s raised to n plus 1 into integral from 0 to infinity e raised to minus x into x raised to n into dx value. Then this x raised to n can be written as this is equal to 1 divided by s raised to n plus 1 as the same, and integral from 0 to infinity e raised to minus x into x raised to n can be written as x raised to n plus 1 minus 1 into dx. Now this is the definition of a gamma function. So gamma function is defined as is written by gamma n plus 1 is equal to integral from 0 to gamma n is equal to integral from 0 to infinity e raised to minus x raised to n minus 1 into dx. So this is the definition of a gamma function. So it is generated by gamma n is equal to integral from 0 to infinity e raised to minus x into n minus 1 into dx. Now instead of n here, n plus 1 is there. Therefore it becomes this is the gamma of n plus 1. This is equal to gamma n plus 1 divided by s raised to n plus 1. So this is the standard function of the LT of t raised to n value. Therefore, Therefore, the LP of t raised to n is equal to, so gamma n plus 1 divided by s raised to n plus 1, and gamma n plus 1 is equal to n factorial divided by s raised to n plus 1. So this is the LP of the auxiliary function t raised to n. Now you go to the particular examples of t raised to n bar, where n is equal to 1, 2, 3, 4, where n is equal to 0, 1, 2, dash. Now in particular, if n is equal to 0, so LP of t raised to 0 is equal to LP of only 1. LP of t raised to 0 is equal to, so that is a 0. So t raised to 0 equal to 1, then it becomes a 0 factorial divided by s raised to 0 plus 1, and 0 factorial is equal to, sorry that matter. So 1 divided by s. So this is the LP of 1 is equal to 1 by s. That is a particular case. And if n is equal to 1, last one. So n is equal to 1. So LP of t raised to 1 is equal to 1 factorial divided by s raised to 1 plus 1. That is equal to, so 1 divided by s square. That is the LP of only t raised to 1 is equal to 1 by s square bar. Then n is equal to 2. N equal to 2. So LP of t square is equal to 2 factorial divided by s raised to 2 plus 1 is equal to 2 divided by s cube, etc. So like this, and take the LP of 1 is equal to 1 by s, when n is equal to 0, then n is equal to 1. So LP of t raised to 1 is equal to 1 factorial divided by s raised to 1 plus 1 equal to s square, that is 1 by s square. This is the value of LP of t. And when n is equal to 2, now it becomes the LP of t square is equal to 2 factorial divided by s cube or 2 divided by s cube. Like this, you can get the LP of any auxiliary function t raised to n. Okay, these are the particular case of t raised to n bar. So these are the standard functions of the Laplace transforms. Just I'm putting the list of Laplace transform the standard functions. Okay. List of, so LP of standard functions. List of LP of standard functions. So in that first one is the LP of 1 is equal to. You make all the list of standard functions. The first one is the LP of only 1 is equal to. 1 is equal to 1 by s. Because remember all these standard functions. While finding the problems, we need all these formulas. Then second one is the LP of a constant a is equal to a by s. And third one is the LP of t is to 80. T is to 8 is equal to 1 divided by s minus a. The s is greater than a bar. And fourth one is the LP of t raised to minus 80 is equal to 1 divided by s plus a. S is greater than a bar. Okay. The fifth one is, so LP of others, LP of sin actually cos sin it is equal to, LP of actually sin it is equal to a divided by s square minus a square, where s is greater than a bar. And next one is the LP of hypothetical cos it is equal to, hypothetical cos it is equal to, so yes by so sin of 80 is equal to, sin of 80 is equal to A divided by S square plus A square. Then it formulation. Let the alpha cos of it is equal to. Let the alpha cos of it is equal to S divided by S square plus A square. Next one is ninth. So LP of P raised to N. LP of P raised to N is equal to, so gamma n plus 1 divided by S raised to N plus 1 or n factorial divided by S raised to N plus 1. And in particular case, LP of P is equal to 1 divided by S square. LP of P square is equal to 2 divided by S cube, etc. So these are all the standard functions of the Laplace transforms. Now I can do some of the examples on this Laplace transforms. So next class we are going to explain about some of the standard functions. Its solutions. And today we will stop here only. Thank you.
ಇಲ್ಲ ನೀವು ಮಾತಾಡ್ಕೊಂಡು ಸರ್
ಮಾತಾಡ್ತೀನಿ.